Okay, guys, now we're going to do some mass to mass problems. So these are mass to mass. Not like your mole to mole, but these are from one mass of one substance to the mass of another in that equation, that reaction's going on. So let's say we have the reaction Na plus Cl2 yields NaCl. The first thing we want to do is balance the equation. So I put a 2 here, a 1 there, and a 2 there. And now it's balanced. Hopefully you guys can see that okay. Okay, so then I say, okay, if I've got 2 grams of sodium, I want to know how many grams of sodium chloride I can make. Okay? So this looks so blurry. I don't like it. But we'll figure it out. Let's see if I can get this back here like that. Get a little light in there a little bit more. Okay, there we go. Sorry. Okay, so okay, there we are. Anyway, so I say, okay, write down my given. 2 grams of Na. I draw my line, right? And, oops. Oh, there we go. Ah, clarity, yay. Okay, so, I'm trying to get all this on here. Okay, so we have 2 grams of sodium. Oh, I forgot how many grams of sodium chloride I need. So I have to go from mass to mole first. You always have to get the mole. So 1 mole of sodium is equivalent to 23.00 grams of sodium. We know that. That way my grams of sodium cancel out. Now I'm at moles. This would be a mole ratio. This mole ratio is going to come from the original balanced equation up there. So if I got moles of sodium up here, I need moles of sodium down there. And I have 2 moles of sodium. It's going to go right here. Okay? And now I'm looking for moles of sodium chloride, because that's what's coming up next. So there's 2 moles of sodium chloride right here. How do I know that's where I need to go? That's what I'm looking for. And then 1 mole of sodium chloride has a molar mass of 58.45 grams. And that way my moles can cancel out. And I'm left with grams of sodium chloride, where I need to go to. So I multiply everything on the top. 2 times 2 is 4, times 58, so 4. 4 times 58.45 gives me 233.80. And I divide it by 23 times 2, which is 46, divided by 46. And it gives me 5.08 grams of sodium chloride. So I would make 5.08 grams of sodium chloride. Now I could have just canceled these 2 out if I wanted to. That's a possibility as well. Let's try another one. Let's see what we have here. I'm trying to keep them simple so we don't have to do so much. Let's say we have water. Let's make water. H2 plus O2 yields H2O. Oh, there we go. Okay, pull this up a bit farther. Let's see if I can get it. No more room there. There we go. Balance it. 2, 1, 2. Easy enough. And I say, okay, if I've got 1.72 grams of oxygen, I want to know how many grams of water will I make. So I start off my given, 1.72 grams of oxygen. And I say 1 mole of oxygen is equivalent to 32.00 grams of oxygen. Why 32? Because it's O2. Okay? Now, this is my mole ratio. Remember, the mole ratio comes from the actual equation, reaction. So if I've got moles of oxygen up here, I put moles of oxygen down there. There's 1 mole of oxygen in my balanced equation. And I'm looking for water, so I put 2 moles of H2O up there. That way my grams cancel out, my moles cancel out, and now I go to the grams of water. 18.00 grams equals 1 mole. I do not multiply it by a 2. That you just get the molar mass of water. And then multiply everything on the top, 1.72 times 2 equals times 18 divided by 32. I would make 1.94 grams of water. Okay? Now, you could also say, okay, well now we got that going for us. How many grams of hydrogen should I have put in there to make this work out? Well, start off with 1.72 grams of oxygen. Start off with what you started off with before. 1 mole of oxygen over 32.00 grams of oxygen. That part's the same. But now I go to my top. 1 mole of oxygen's there. Oxygen down there. It's 1 mole to 2 moles of hydrogen. Why 2 moles? Why hydrogen? Because that's what I'm looking for. And then 2 grams of hydrogen equals 1 mole of hydrogen. Moles cancel out. So I take 1.72 times 2 equals times 2 divided by 32. Try it one more time. Times 4 equals divided by 32. I was right. So I should have 0.22 grams of this. And look at this. If I add 0.22 plus 1.72, I get 1.94. What goes into an equation has to come out as well. Okay? So these two sides have to equal what's made over here. Let's try one more, and then I'm going to set you on your own. Okay? And I'm going to have a video you can watch as well. Not me, obviously, but if someone else. So let's say we have, let's do a bigger one this time. Let's do a Ki plus AgNO3. It's double replacement. So it's going to make AgI, which will be my solid, plus KNO3. And it's already balanced, which is lovely. So it's 1 to 1 to 1 to 1. And okay, if I say I've got 2.0 grams of potassium iodide, how many grams of silver iodide will I make? Why don't you pause the video, see if you can do it yourself, and then come back on in a few minutes and see if, check your work against mine. Okay, so if I've got 2 grams of Ki, and I know 1 mole of Ki is equivalent to, oh goodness gracious, I gotta look up iodine's mass, iodine mass. It may not be the same as yours. So 126.90 plus 39.10. So it's 166.00 grams. Now remember on this part right here, I have to look up at this equation, but it's all balanced. That's good. So 1 mole of Ki is equivalent to 1 mole of AgI. And that moles cancel out. And I know that 1 mole of AgI is equivalent to 0.9 plus silver is 107. Let's see, silver's mass. Sorry, guys. Oh, there we are. Yeah, it was 107. Yeah, 107.87 plus 126.9. So 1 mole of silver iodide is equivalent to 234.77 grams. Okay, and everything cancels out. Grams, grams, moles, 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 moles. I'm left with grams of silver iodide, and that's what I'm looking for. So I multiply everything on top times 2 equals divided by 166.00, and I should have had 2.83 grams of silver iodide. I can't call it potassium, silver iodide. Okay, so that's how you do mass to masses. They're pretty straightforward. We'll do one tomorrow, a lab tomorrow with them, and hopefully, please praise God, I'll be back on Tuesday. Thanks, guys. Have a great day.